This is Andy Zaski, VP of Sales Marketing at Tolomatic, and we're excited to bring you another ToloTalks. This is Application Week. We've gone through some medical slash pharmaceutical applications. Yesterday, we dove into a number of food and beverage applications. This week, or today, we're going to work on talking to you about a lot of automotive and then tire applications at the end. Maybe a place you wouldn't normally expect to see a linear actuation, and then we'll finish up the week with defense and some aerospace stuff tomorrow on Friday with our last of a series of 4 applications. And the way that we're doing this is a series of panelists, if you will, from our sales team have all agreed to jump on the line here, and we'll be sharing some of their experiences from different applications they've worked through in the automotive world. And obviously automotive is a key market for Tolomatic. It has been historically our largest segment. A challenging space in the last 6 weeks, for sure. We're hopeful that as the economy gets back up and going and people start driving again here in the coming weeks, that this will continue to grow and get back on track. So with that in mind, we thought it was a good opportunity to summarize some of the activity we've done there. And obviously a lot of this would be translatable to other applications and industries as well. So be thinking about the other ways this type of actuation could happen in other industries. With that, I'm going to kick things off, and we are lucky enough to have our first presenter from Europe here. So Stefan Renaud-Betts, welcome, and if you could take us through the next 3 applications, that would be great.
Yes, good morning, everyone. This is Stefan calling from Strasbourg, France. The first application I'm presenting here is a spot welding application with our servo weld product line. And I'll talk about a particular project that we were able to convert a large German car manufacturer from servo pneumatic over to electric. And their main requirement was to get rid of high pressure air. So they had a 175 PSI 12 bar air system in their plants, which is very costly because you can't turn it off because there's so much pressure in there. If you turn it off and on, it causes leaks. So, but we had to come up with a solution that would have similar space constraints as a pneumatic cylinder. It had to have compatible force repeatability. Those servo pneumatic systems have very good force repeatability. It had to be fast. And they also wanted to work with a company that was global. Andy, next slide. So this started on February 2017 with a call from the head of automation. And the guy called me and said, "Oh, I've seen your products and your technology on a trip to China. I really like it, but I'm a bit concerned about working with a company from China." And so I told him, "Where are you?" And he said, in north of Germany. So I'll be there tomorrow. And apparently you have a few things to learn about Tolomatic because describing us as a Chinese company is not exactly accurate. In October, we provided the first prototype. We had the design freeze, and earlier this year we got the first large order. And on this product, the value they got is the best-in-class spot welding are actuators, from which the IMA series coming has been designed to achieve the best force repeatability. So we have these skewed windings, and here's a picture on top of our skewed windings, and this allows us to have a very low cogging force. So independent of the position of inside the motor of the rotor and the stator, you are getting very consistent force, which is very, very important. It makes our actuator a little bit longer than some of our competitors, but the force repeatability is a key argument here. And it's also, they wanted a supplier that could support global projects and also have people on the ground to help. And this is something that Tolomatic has established over the year. We have operations in key automotive markets in Asia, in Europe, and of course, North America. And they also needed a supplier that was agile, because on those large projects, there's concurrent design. So sometimes we're getting requests, a few, like we need 5 less of the size 33 and 4 more of the 44. And they need suppliers that have that flexibility, which Tolomatic can offer. Next slide. The next application is also a welding application, but this time an application on projection welding. So projection welding are typically pedestal installations. The actuator is not mounted on a robot, on a weld gun on robot, but on a pedestal. And they are typically installing nuts with these projections or dimples. And this is in this application, you can see the main axis for force, and you also see with an incline something that is called a laser tongue in the industry, and it's a nut placement unit. The nuts, as you can see, have dimples, and what happens when you press and start to push the current, at some point those projections melt and collapse, and the solution has to be able to follow the nut as it collapses, and it's about 3 millimeters of movement of 10 milliseconds. It's very hard to do the servo control on something that fast. So the solution that we came up with would be shown on the next slide. So we came up with a design where we embed inside our linear guide that we can mount in front of our actuator, a Belleville washer, a spring stack. And this allows when the rod is applied on the nut, there is force built up in the spring, and when the nut collapses, basically the rod follows the nut. So it's got very fast response, and this event prevents problem, because if the force doesn't follow, then resistance goes too high, and then you make a big hole, and the weld quality is poor. So, and this allows customers to get all the benefit of servo electric actuation. And in particular, for some complex parts, you want very good motion control. So, next slide. The third application I'm presenting is something quite exciting to us, because it's fairly new, and it's a solution that Tolomatic offers, again, in the area of projection welding. So on the picture we showed previously, there was a pneumatic actuator, this little pneumatic actuator, which is called a laser tongue, because it very quickly, with gravity, comes and places a nut onto the electrodes. And the challenge with doing this with pneumatic is over time the rods gets loose, and the customers start to drop more and more nuts, and nuts that are dropped cannot be reused, and sometimes it also causes delays in production. Another issue that we see often is that with a pneumatic system, you have to wait until the rod is fully retracted and the proximity switch tells the PLC you can start welding, the rod is fully retracted. With a complete servo electric system, we are now able, or the customer is now able to start the welding movement when the rod of the nut placer is clear enough to start the process. So it's a great gain in an issue that we see as well, which is mentioned here, is when this rod and those pneumatic laser tongues get loose, there is a hula hooping system where the nut starts to spin along the pin of that nut placement and sticks with the rod and doesn't come down. With our solution, we can eliminate this through the guidance systems that we have created. Yeah. And we have a little video for you on the next slide. You can see it's in slow motion. I mean, the rod is actually bringing the nut at speeds faster than gravity to make sure they don't fall from the rod. So it's it's a very high speed, and this is possible thanks to our special LZT linear actuator that allow this type of speed, which is not possible with a regular ball screw or roller screw type actuators. All right. So here is a description in a bit more details. You can have an inside look at our LZT actuators. What you can see is it's actually a belt actuator, a linear belt actuator, like our rodless, but mounted on it, our engineers have developed a high-speed rod system. So a lot of thought and work has been put in allowing a rod system to operate at the speeds and the accelerations that are possible with this type of solution. And we have over the years, developed this product into different applications, and certainly this one with nut placement is one of the most exciting for us. You will typically find nut placers in the automotive industry where mostly doors and side panels are being produced. So they're often found at part suppliers, more than I would say like the car manufacturers that would do the final assembly. At least in Europe, there aren't that many projection welders at the car manufacturers. They're mostly at the tier ones. And for more information about this fantastic LZT, I invite you to contact your local RSM. Thank you. And I have one more at the end, so I don't say goodbye for long. So talk to you later.
Thank you, Stefan. Appreciate it. Very good. Yeah, the LZT, this is the application it was originally developed for, but certainly we've found other applications where a fast rod style actuator may be of interest in some pneumatic replacement sort of situations where you can control very precisely the speed, the movement, the acceleration, the deceleration, the location of it, multiple, sort of infinite positioning capability. So perfect. Along with that, we're going to stick with our welding theme here. This isn't exactly on an automotive car itself, but it is welding related and has to do with transportation more generally. So Keith Hogan.
Thank you, Andy. Just first of all, the application is with a company that does wire welding, not wire feed welding, but wire welding. And most of this is for some kind of a construction type situation where they could be on road construction. And maybe sometimes you drive down the roadway and you see they're working on a roadway, and you see these little trusses going through the concrete forms before they actually pour the concrete. And another thing they use these for is for buildings. So if you have high rises and that, a lot of times they're pouring the concrete for the structure, etc. So moving on, the end user, the pain point was hydraulics. Not so much the cleanliness, but although that, the upkeep and the cleanliness and all that is obviously on the front end as well. But they're finding out that they need to be more precise, especially each one of these types of structures has, if you call it maybe a recipe. And so you have different thicknesses of wire, you have different rates at which you can run that, you have different bends, etc., for structural strength. And they were finding that based on hydraulics, the end product was not consistent. You get spring back and it was not easy to control. Another thing they found out was that when they make these trusses, every little cost is important because the competition is just terrible. So they found out that if they would go to electric and have more control, they could make a more easily stacked truss. So if you see a stack of trusses going down the highway on the back of a flatbed semi-trailer, the more tightly those are packed and stacked together, the less the trucks they have to use and the more cost efficient they are. Another thing they found out is that as time goes on, certifications, liability, and that type of thing is a growing fear. And they found out that, you know, if you're building a high rise and you've got these things in a high rise and all of a sudden one corner crumples down, big problems. So that, and the fact of the matter is that most of the operators that run these things are relatively low paid entry-level people, which don't really care about anything but the paycheck at the end of the month. So that was a trouble. And then, of course, I mentioned the mess and service. Go ahead, Andy. So we got involved in this application. We have a hydraulic machine here that they're running in the video, and they wanted to go electric. So we kind of came second into it because the competition was Diacont, and they were interested in a very compact design because of the space that they had in the factory. So Diacont was in there. They're a relatively new player on the market, and we went in there. Diacont was aggressive, so we went in and we had to be aggressive as well. I think we were still higher than Diacont, but we did build up some respect and some confidence in the customer that inevitably they came our direction. We were able to do force and speed repeatability, thermal modeling for since this is a continuous operation, we had to make sure that the nut and the screw were not going to exceed our thermal capabilities. And because we had done that type of testing, we eventually won that business. Now, each machine has 8 hydraulic cylinders on there, and the hydraulic cylinders were replaced by IMA 33s, so 8. And then in the factory, they had 30 different lines. Now, we're still working through the testing on the first unit, but once that all plays out, there may be a certain number of those machines they would transfer over. And they were sure to tell me that they weren't going to do all of them, but they did struggle with a few diameters of the wire, and that they were sure that that was going to, at some point in time, cause us to revamp additional units.
Thank you, Keith. We'll keep moving on with Mr. Sondrigo.
So this is a general industrial, but they do a lot of automotive as well. Traditional press brake manufacturer in Ohio. Now they've been a traditional hydraulic customer for, I don't know, 80 years or something. So they have a very close relationship with their hydraulic distributor. And when it came time, when electric actuators increased in capability enough, they decided to go with their hydraulic distributor to buy the item. So what we have going on here is there's like a 2-axis system right near where the jaws come together on the press brake. And then there's 2 roller screws in those large cylindrical columns up there. Now this is on their smaller size machines. Electric still can't really do hydraulic top end. You know, they can't do 2 million pounds of force or something. But for smaller machines where you don't want hydraulic leaks or anything, they have an electric version, and that's what you see pictured here. And the biggest issue with selling to this customer was the distributor, because they had offered such good service. They stocked for them. Fortunately, Tolomatic had better product. Cost, delivery, and performance better than Rexroth. Our roller screws, certainly the delivery and costs are better than the rollers. And so we won it on product performance. Now we have to keep the business, and I have known this customer for years. I actually did design their hydraulic manifolds for a long time, so I had a bit of a relationship as well. But so we're using a combination of MXESs, ERDs for the vertical lift, and then roller screws, just like we would put in our actuators, not customized in any way. The customer had to do their own machining. Solid customer though. All right, Andy.
All right, thanks, Brian. One more.
Okay, this is, I think, the biggest project I've done with Tolomatic. So this customer is manufacturing all the brakes for the F-150 trucks. That's the #1 selling vehicle in the world. And we really dealt with the end user here. We had a distributor who sold all the servos and such, but the end user is the one who really drove product spec. and they wanted absolute reliability. That was their thing. So we do L10 lives on our products, and they want the L10 life to be at least 100 years. And why is that? That's because if their line goes down because of product failure, it costs them $2,000 a minute. And if it takes 20 minutes, that's the cost of almost all the actuators on a line. It's a traditional Japanese company, so they'd used IAI for years. And their pain point was they wanted a local supplier to the US who could support them, and they wanted good distributor support also. Next slide, please. What really sold this was the end user people came to the Tolomatic factory. They touched the product, they met our engineers, they built up a comfort level that we could support them and that our product was what they needed. We're still in the midst of this. In distributor dollars, if you include their servo motor sales, this was probably a $6 million project. We're in the last phase now. So our sales value, as you see down there, we had truly the best, most reliable product. Distributor was wonderful. Customer visited our factory, and we showed them our capabilities, our lead times, and our performance. So it's $1 million, millions of dollars of product here. So it's out there if you guys want it. All right, Andy.
Great. Thanks, Brian. Yeah, the key was their factory visit, and while they were here, they saw some of these products that weren't as easily recognizable on our website and stuff, and started thinking about us in other applications, ERDs, MXPs, et cetera. So really great. Dave Schmidt, lithium battery manufacturing.
Thanks, Andy. Yeah, good morning, everyone. So yeah, as the level of interest and entry into the marketplace, automotive marketplace of electric vehicles has increased, so has the requirement for lithium battery manufacturing. So this was a OEM and special machine builder that was looking at using hydraulic cylinders to compress these discs. Each of those ripples is a disc, a battery, like a large oversized watch battery, and all stacked together. So as they press those lithium batteries together, they need very precise control and push to a distance at a specific force. So a hydraulic cylinder couldn't provide that position feedback and everything, and any hydraulic leaks onto the discs would contaminate the discs and cause them to become scrap. So we were able, with our RSX 96, to provide a consistent and uniform pressing force and positioning. So here's the machine as it was designed, utilizing a Cole-Morgan motor on there. And you can see the ram just is coming down and pressing on that mandrel there to position the disc at the right location. It was about 15 tons of thrust capacity. And we were higher priced than the hydraulic. Hydraulic and pneumatic was going to be about 50% less, but they opted, because of the performance and precision, to spend the extra money. So sometimes you can still win with a higher priced product.
Great, thanks, David. Enrique.
Good morning, everyone. Thanks, Sandy. So yeah, this is also for an automotive application. In this case, we're also trying to replace this pneumatic technology. As you know, when you have a welding application, these applications could be millions of cycles per year. So basically, the pneumatic technology wasn't really cutting it for the client. They needed a high number of cycles per year, and also they needed a lot of precision to move this table in two axes of motion, X and Y. This basically what it did, it was position that table in a way that they could weld those parts you see there in green precisely. So pneumatic wasn't being able to be controlled both in position, velocity, and besides that, the number of cycles, the seals and all that were being compromised too soon. So also the contamination of the weld That also was a factor to choose one of our actuators. And also the customer wasn't really having a lot of good technical support from their suppliers. So that was a big issue for them too. Next slide, please, Andy. So we started defining the application parameters. One of the main things when you're trying to replace other type of technology is to get the right parameters. Talking about force or speeds and all that, sometimes that's one of the main things you need to have very precisely from the customer. And for some customers, this is difficult to do because they don't really know how much force they're developing due to the type of technology they're using. For example, in pneumatic, all is really theoretical calculations of force. To get feedback, it's kind of complicated to get. So once we got that, we sent an initial proposal after a couple days. After a week, we sent the final proposal with one of our actuators. These are some belt-driven actuators. These belt-driven actuators, they can be really fast, but also they're very precise. We're talking about 2000s, plus minus 2000s of repeatability. And some of our belt-driven units, they can go up to 5 meters per second, which is 200 inches per second. So they're fast and precise. And also, you know, it was like the perfect candidate for this application. So we provided this solution, XY axis. We integrated this solution to accept a NIDEC gearhead to increase the torque capabilities, and also an Allen Bradley motor. These, of course, reduce the maintenance costs because you didn't have any leaks like you were going to be doing with the pneumatic solution. And also, well, the downtime that you don't need to be, you know, doing changes of sizes and all that with a pneumatic solution. Besides that, you have all the quality of product being produced. Really, you're not producing scrap, you're producing good products, good welds. And yeah, that in the short or long run, both of them, you get a better cost. So the first order was for $5,000 per machine, and there's potential to replicate these in 8 more machines. So we're pretty sure the customer will see the benefits and go for it.
Thanks, Enrique. Perfect. Appreciate it. Bob Junko. Bob's got an application here with a simulator. Bob, you have to make sure you're not on mute here.
Okay, how's that, everyone? Good morning.
Perfect. There you go.
Terrific. Boy, this is one of the more fun applications we've been involved with since we were actually able to drive simulators, automotive simulators. The company takes full-size vehicles and replaces suspension parts, electronics, and turns the roadworthy vehicle into a simulator where you drive different road courses. Andy and I had the opportunity to experience a Corvette driving on the Nuremberg Ring in Germany, and it's just incredibly fun. This application here was interesting because we had our marketing department involved with the customer, and we did a joint marketing. And you guys all know the brand of vehicle that's here. This one is a hydraulic replacement and a lot of fast, short moves. Real 100% duty cycle required and quiet operation. So this is an automotive car show circuit, and the manufacturer of the vehicle, of course, is trying to promote their high performance vehicle line. These typically, a Hellcat or a vehicle of that nature, it's more difficult to get people out and really experience what the car is capable of doing. So the Tolomatic actuators on the 4 corners of suspension were able to achieve this. Let's go to the next slide, Andy. So our marketing department got involved, and the cars are on the car show circuit. And if you go to a major auto show, you can drive these vehicles and race them side by side. Sorry about that. And just an incredible application win. They do a lot of different simulators for vehicles, semi-trucks, fully autonomous driving, probably some of the future applications we'll get into. But these were RSA series actuators on the corners, RSA 32s. We have other applications for major auto manufacturers that are drive-up platforms, where you can drive a vehicle on to experience the suspension feel on the vehicle. But just an incredible win, and really good example of a joint marketing, getting Tolomatic management, marketing management involved with your customer to help promote their product. Promotes their product, they sell more, you guys sell more actuators. It's a great thing to remember if you have an account that's amenable to working with Tolomatic marketing. So we were able to move in, change out some actuators that were more hobby style actuators on smaller platforms. And once the customer saw the quality of the Tolomatic product, he's set for life. He's not going to change to any other actuator supplier. The quality has been 100% uptime on the car show circuit, never a failure, just a lot of fun, and it really draws a lot of attention, to the application because it's loud. You really get the feeling of accelerating down a drag strip in these as the Tolomatic actuators work, and you feel all the input on the pedals, the steering wheel. It's just a very interesting application. I think Andy could also attest to the fact that driving the Corvette was very fun. So our delivery, superior delivery, quality versus the competition, and then the high durability, the endurance technology of the Tolomatic actuators made this a real win. So
it absolutely was fun. It was just a little outside my budget and wouldn't fit in my basement, but otherwise I would have picked one of these up. You got 4 actuators per vehicle, one coming this way, the other one coming this way. The pitch and the yaw of the vehicle back and forth, and the bouncing of it. It is quite an experience and a lot of fun. I highly encourage you to try and experience that if you can, and a great application for us around simulation. So, thanks, Bob.
You bet.
To finish out today, we wanted to quickly take you through a tire plant and some of the applications we've done here. So we're going to go a little fast, and there is quite a bit of verbiage on each slide. So hopefully you're able to sort of read through, and we'll highlight a couple things as we go. But on the left here, we have done business with all of these different tire companies. A lot of it has not been on new builds. This is mostly on retrofit. So going in and improving their quality, their operation, replacing older technology, looking for areas of improvement, and lots of interesting opportunities. This is the tire manufacturing process, and you can go watch YouTube videos and see other things. Basically, natural rubber comes in, you come through this entire process, depending on what kind of tire you're manufacturing, putting the treads on, and then at the end, you're testing the finished tire and getting that out to the customer, and at some point doing reclamation. So wherever you see a red arrow, we've put Tolomatic actuators into these different places in that tire manufacturing process, and we wanted to just give you a glimpse at some of those. So Brian Staines, you just highlight a couple things here.
Yeah, thanks, Andy. Good morning, everyone. This is a lifting material conveyors. This is really in our wheelhouse. I spoke briefly yesterday on the food and beverage about this on conveyor systems. We do it with the ERD in the food and beverage industry for washdown. Well, here's a RSA 32 rod style. The customer just wanted to upgrade their hydraulic units for better control, basically. And we're able to do that with electric actuator versus hydraulic and pneumatic, obviously. So it improved their control and positioning, helped the flow of material better down their conveyor system. Obviously eliminated messy leaks and contamination of product with hydraulics, and just increased production overall. That's really in our wheelhouse. This is a very easy application for us. We do it, like I said, in food and beverage and in the tire industry and the auto industry as well. So very easy, simple application for us.
Thanks, Brian. Yeah, any sort of material handling application, this would be applicable. So Dave Schmidt, rubber cutting.
Yeah, so thanks, Andy. This also is a hydraulic replacement application. So as that raw rubber comes down the line and is ready to cure. It gets slit and edge trimmed. They call it a calendaring process. And we can move the knives and so forth. So you can see in the animated sketch there is how it comes down in bulk, and they might cut it into a slab or in the actual inset photo above. That's one of the slitting processes here, where we used MXB actuators here. For me personally, I've also installed RSAs that Brian Staines just referenced for the vertical axes and moving the blades up and down. So kind of an XZ type application in this process.
Great, thanks, David. Colton, tread application?
Thank you, Andy, and howdy, everyone. Yeah, this was a interesting one. So this was the case on some sizes of tires. They take the tread and apply it to the core, so the casing. In this case, they wanted to hold a very precise force and also have a record of what force was applied. They had a pretty tight size requirement, so that led them to use our IMA, it's motor actuator all-in-one. In this case, it decreased the defects since they were able to hold a more precise force, and obviously with electric actuators, having the ability to record that force and save it for later was very important. So pretty much sums up the application. Thank you.
Great, thanks. Product feeding, Mr. Staines, back to you. Brian, I think you're still on mute.
Sorry about that. Yes, I was. So again, product feeder RSA 32. There's a trend here. RSA line is, or our series of RSA actuators is a very heavy duty, robust actuator in the tire manufacturing facilities. I have 5 or 6 of them in my territory, but the product feeder here, they were using hydraulic actuators. They're experiencing position control issues, accuracy, repeatability, the same thing you're going to see with pneumatics and hydraulics. So there again, they were hesitant a little bit to go electric because they've been hydraulic for years. We put an RSA 32 on there with obviously controls, and it increased their throughput, increased the speed, accuracy, repeatability, eliminates contamination of the hydraulic stuff. And two, if you're familiar with a tire manufacturer, floor space is a big need for these guys. So eliminating these big power units and things like that from a hydraulic standpoint is a key issue for them as well. So overall, a good application here.
Great, thank you, Brian. We'll go back to Colton.
Thank you, sir. So as with many large manufacturing facilities, they struggle to find maintenance staff that are smart and know how to do everything that they need to do there, keep them employed. And so anyway, so in this case, they were able to reduce their maintenance and have lower costs there, since the electric's more reliable and has less maintenance. So in this case, they had a set of RSA 64s moving in synchrony during the tire tune-up. So pretty straightforward. Long-lasting actuator, they backed into the RSA 64. In this case, they had a life target, so they boosted up a frame size into the RSA so that it would last the appropriate amount of time. Thank you, Andy.
All right, thanks, Colton. And Mr. Sondergaard, green tire transfer.
This is for a plant that made big, like semi-truck tires. And this is the tires would come down, they call them the green tire, and a pneumatic cylinder would lower, grab the tire, then swing, another cylinder would swing at 100 degrees, drop it into the tire press, it'd sit there for 4 minutes or so. So the cycle time was about 4 minutes, and this is a common situation. How are you going to replace two $100 pneumatic cylinders with a $20,000 servo-driven system? Well, the way we were successful here is when the tires swing, they would rock back and forth when they hit the end of stroke for about 3 seconds. And that's on each side, right? So 6 seconds total out of a 4-minute cycle. So we were able to trim about 6 seconds by converting them to electric. That means an extra $5,000 a day of tires that they put out and about $2 million a year. So the return on investment was perhaps a week. And once we showed them the benefit of the increased productivity, and this was the choke point in their plant, it was a really easy sell. So, and they bought 20 of these for all 20 tire presses. So increased productivity is a really good way to sell against pneumatics. You're not going to sell on cost for sure. Thanks, Andy.
Great point, Brian. Thank you. We'll go back to Mr. Staines one last time here.
Yes, tire diverting and sorting. This is actually a pneumatic application, MXP63P. There's a ton of these in every tire plant. Very good application. As much as we like to sell electric, this was definitely a pneumatic application just because of where it's at in the plant. The competitors' units were failing due to moment loading and things like that. So we put the MXP63P in with a profiled rail, very big, robust pneumatic actuator. Eliminated costs of scheduled downtime is the main thing, because you have a big plant like these tire plants. People are working 3 or 4 shifts at a time. They do not want to come in and replace actuators. It's downtime and cost money and everything else. So basically the MXP63P was just a very robust actuator with the profiled rail, no failures in years. We've had these in many plants for years and have no failures. And there's a bunch of them. So there's a lot of opportunity for the tire diverting and sorting. Thanks.
Great, Brian. So we got 2 more left here, and here's one slide and a second application after this. So David Schmidt.
Thanks again, Andy. So yeah, this, as you mentioned, is 2 different inspection applications. So as the tires are continuing to move on down the line and in the manufacturing process, one of the final phases or stages is inspection. And so on the left-hand side, we were using the MXB63P for moving the tires and adjusting them under the camera. And on the right-hand side, the wheel is actually attached to a mandrel that spins the tires for trueness and spins it in front of a camera. So you've got 3 different ones shown there, a left, a right, and a front. And that moves, the actuator moves the wheel up and down. And then the tread depth gets checked, the seat of the tire, the inner seat of the tire gets inspected for trueness and all the critical specifications, and make sure that you're getting a quality product. So.
Great, thanks, David. And then we're going to go back across the ocean to Stefan in Strasbourg and finish up our applications for today. Thanks, Stefan.
Yeah, so this application is actually directly related to the one that Dave was showing. These actuators, these high force actuators, are used on the machine that do the profile with the cameras, the profile check. So at the very end, you are pressurizing the tires at double normal pressure, and then spinning the set. This customer was looking at moving to higher size tires, and needed to change their inspection machines, and they had a choice to make between servo hydraulic or electric. And the servo hydraulic power unit was actually more expensive than electric, so it was a no-brainer in this case, and they would gain a lot of benefit in terms of reduced maintenance, as we discussed before, and better control of their process. So this basically replaces a large press actuators, a large hydraulic. Yep.